Okay, so let's go through a couple examples. Take this concept a little bit further, and then your homework for your lesson 7 notes is going to be the Now You Try pieces, numbers 1 and 2, that are also attached in this packet. So let's look at example 1. Factor this cubic function given that x equals 2 is a 0. That's what's being asked in example 1. So you're given a cubic. That cubic happens to be in standard form and all values are represented. And you're given the fact that x equals 2 is a 0. The first thing you want to pull out is the fact that your x equals 2 is a 0. So you know x minus 2 is a factor. And if you know x minus 2 is a factor, you would set up your long division with x minus 2 on your outside. Since it's a factor, it's what you had before you got x equals 2 as a 0. And your whole cubic in standard form with all your values represented goes on the inside. Long division, I've got x is my leading outside x cubed is my leading inside x, so I'm missing x squared. So x squared times x gives me x to the third. X squared times negative 2 gives me negative 2x squared. Subtract my terms. Double negatives with the terms below. These two double negatives give me positive. This cancels, gives me 0, which is what I wanted. This happens to give me 0, cancels out. Since I have 2 left on the inside and 2 left on the outside, I need to bring down both terms together. I need a negative 9x on the inside, but I only have an x on the outside, which means I'm missing a negative 9. Negative 9 times x now gives me negative 9x. Negative 9 times negative 2 now gives me a positive 18. Subtract both terms from each other. Double negatives with the term below it cancels out. And this should have been an 18 because I had an 18 to begin with, so this should be an 18, which means 18 minus 18 is also 0. When I'm left with nothing as my remainder, I know that I just took my cubic function and factored it into 2 separate groups, and those 2 groups are what I use. X minus 2 is a factor, and I also take what I have left over after I did my long division. From here now, x minus 2 and my group x squared minus 9 are my 2 factors for this cubic function. But I'm not done because I know that I can break down this quadratic into 2 more groups. Since you know x squared minus 9 are the difference between 2 perfect squares, x minus 2 obviously stays the same because it can't get any smaller. This guy right here can break up into x minus 3, x plus 3, and that's going to be your answer. The directions were to factor this cubic. You factored it down as far as it could possibly go, and now you've got 3 separate groups or 3 separate factors that represent this cubic. So if I went through and I multiplied and FOILed and then multiplied all 3 of these groups together, I would get the same cubic up here back out. You can also double check, just make sure that x to the 3rd power means you should be getting 3 x values back out of that group. Last but not least, we have example 2. In example 2, my directions are a little bit different. In example 2, it tells me one of my zeros, just like example 1 did, but the directions are to find the other zeros of the function. So it's not asking me, like in example 1, just to factor my function, but example 2 is actually asking you to find the other zeros. Okay, so we start this off the same way that we would start off the previous example 1. Luckily, if you notice, example 2 uses the exact same numbers in cubic functions as the previous one, so we're not going to have to necessarily do any work here. If this was different, again, you'd pull out its factor. The factor here is x minus 2, that's your factor. So x minus 2 divided into my cubic function here. Luckily though, we already did this work up above in example 1, so we don't have to go through and do the long division again since I already did that before. All I know is that since it's the same as the above, I'll write that down, same as example number 1, I know I get 3 groups back out. But those are my factors. That's not what my zeros are. So I have 3 factors for this cubic function once I went through and did my long division. Now to find my other zeros, I just set all of my groups equal to 0. That's what I'm going to do. I'm going to set all my factor groups equal to 0 once they get as small as they possibly can. Once I do that, x minus 2 equal to 0, I get x equals 2 as a 0. Set x plus 3 equal to 0, solve, I get x equals negative 3. And then x minus 3 set equal to 0. So I get x equals 3 as my other 0. So those are my zeros of my graph. And if I had to sketch for a moment what this would look like, I know negative 3 would be here. I know positive 2 would be here. Positive 3 would be here. And because it's my leading x, my original leading x is positive, I know I'm going to have my arrows in a positive direction. When I connect my arrows, I should get kind of like a positive slope out of it. And we have something that looks kind of like this. It's going to not necessarily go as high or be as low as my max and my min here, but the idea is that you're going to have a graph with a similar type of look to it. Okay. Just make sure though that you know what's being asked for. In example 1, they were just asking you guys simply to factor. So factor just means all you had to do is break it up into the smallest groups as possible. Example 2 was asking you to actually go through and find the zeros. So that was asking you to take your factored form once it was factored and set everything equal to 0 and solve for the x's. So now at this point you've got 2 more problems to work on. The Now You Tries number 1 and number 2 that is attached in this packet. The next time we meet for class, we'll go through the answers together and make sure that you guys have no extra questions. And if you have questions, just kind of sketch some questions down as you work through numbers 1 and 2 of the Now You Try so that you guys are ready to go the next time we meet.